Hey math kids, today we're going to talk about the sum and product of roots theorem. So if we're given a polynomial defined by the stuff written in red, that looks really scary, but it's really just talking about something like 3x squared plus 2x plus 1, and where a(n) is the leading coefficient, and then a(0) would be the constant, and then anything else would be the things in between. I think I'm just going to show you in the context of an example how we use this. So if we're given 2x cubed minus 7x squared plus 8x minus 1 equals 0, once again a sub n is going to be 2 and a sub 0 is going to be negative 1. Now if we're using this sum formula, this is a of n minus 1. So if this is a of n, 1 back from that is going to be a n minus 1. So in other words, it's the second coefficient. So we're going to do negative, and then it's negative 7. So it has the negative sign here, and then whatever it is. And then the leading coefficient is 2, and so the sum is going to be 7 halves. Now if the product is negative 1, n is whatever the degree is, and so the highest power of x, so that's 3, and then our constant term, because a sub 0 is constant term, and then a sub n, which is the leading coefficient. Negative 1 to the third is negative 1. We still have that negative 1 there. Negative 1 times negative 1 is 1, and so our product is 1 half. Okay, I want to keep these formulas on here, so I'll just erase this way. Okay, the next one, we're given p of x, it's equal to 3x to the fourth minus 12x cubed plus cx squared plus dx plus e. And we're told there's a y-intercept at 180. Then we have x-intercepts at 2 and 6. And it doesn't meet the x-axis anywhere else. Okay, there are other zeros, m plus or minus n I, and n is greater than 0. Okay, so we're going to use these sum and product formulas over here. Okay, so if we just took the roots, so we know that we have 4 roots because fundamental theorem of algebra says we have 4 roots. So we're going to have m plus ni plus m minus ni plus 2 plus 6 because of the x-intercepts. So if we do m plus m, we get 2m, ni, negative ni, those are going to cancel, and then plus 8. So that's one way to find the sum. Now if we use the sum formula, we're going to take the second coefficient, we're going to get negative 12, the negative version of negative 12, so negative and then negative 12, and then leading coefficient is 3. So that's 12 over 3, that's going to give us 4, and so that's also the sum. So we found the sum this way and the sum that way. Now we can subtract. 2m is equal to negative 4, and m is equal to negative 2. Okay, now another thing to note is that the y-intercept is the e term. The constant, like the constant is that. So if we multiply all the roots together, so I guess I'll just write those out again. M plus ni times m minus ni times 2 times 6. So if we multiply these, we're going to get m times m squared negative ni positive, or n mni minus n squared I squared, then all that's going to be multiplied by 12. Okay, this and this cancel. This is negative 1, so it changes that to a positive. And so we just have m squared plus n squared times 12. We know that m is negative 2, so we can plug that in. So that's going to be 4 plus n squared times 12. Distribute the 12, we're going to get 48 plus 12n squared. And now if we use the product formula up here, we just take negative 1 raised to the degree is 4. Then we times it by the constant, which is 180. And then we divide it by the leading coefficient, which is 3. So negative 1 to the 4th is just positive 1, so that's not going to affect it. So we have 180 over 3, which is equal to 60. So we found the product two different ways, so we can set it equal to each other and just go through the algebra. So subtract 48, subtract 48, that's going to be 12. Divide by 12, divide by 12, so n squared equals 1. So n is going to equal plus or minus 1 if we square root both sides. Alright, and so that's it. So we could think of n as just being 1 because the plus or minus is already there. And so those are our two answers. If you need additional help, please come to MathLab. Until then, calculator.